So I pulled up these classes here. I just full screen the video now, and the video stopped, so I had to restart it. So I just clicked on these classes, the ones that we already created: binary tree node and link binary tree. So what's going to happen here is, I think the link binary tree, we're going to instantiate a link binary tree here, an object for our decision tree. So link binary tree of type string objects name tree points a new link binary tree of type string objects, no parameters. So where's a link binary tree? No parameters. Well, guess what? Which one takes no parameters? So here we go. We're instantiating an object of type link binary tree with no parameters. So we're going to go to our link binary tree class, right? We're going to go to the constructor, because that's the constructor sets up the object every time we instantiate an object. We're going to go directly to the constructor, because that's where the object gets set up. Then we're going to find the constructor with no parameters. So is it this one? Is it this one? Or is it this one? Well, it's this one, because this one takes no parameters. So here we can see, creates an empty tree. Public link binary tree takes no parameters. Our binary tree node root object reference variable is set to null. So currently our root is null. So hopefully that clears up any confusion. So current node right now points to tree.root, which points to null currently. So that may change once it loops. So just for now it's null at this point. Then we'll have an if statement. If tree.root, so we're going to access our object tree. We're going to access our tree object, use a dot operator. So we're going to say, okay, link binary tree, right? Our object tree. We're going to say dot root, so we're going to go into our link binary tree object. And when we use the dot operator, it's going to access its instance data. So we'll say, okay, well, our tree, we're in link binary tree. We've called it tree, so this is one of the objects. So remember, a class is a blueprint of an object. So you can create many objects from one class. So this is one of the objects. So we're going to say, okay, well, we're going to take our tree object dot. We're going to access this instance data here. It's root, so it's global root. We're going to access. You can do that with a get root or just a dot root. So we have a class called get root node or something. I think before I said we could have called it just get root, so we could say tree.getRoot, because where is tree.getRoot? So we have a get root here, get root node. It does the same thing, it just returns root. Or we can, so there's different ways to do it. Or if it was strictly more encapsulated, we would use this method, get root node. But it's not strictly encapsulated, so we can use a dot operator to access root or mod count, right? So we have up here root or mod count. And if we were accessing a root, link binary tree root, if we were accessing something else, so we have nodes here, right? So we have our root. Can we say something else? Binary tree dot root dot get element, get right, set element, set left. So we could chain these dot tree dot root dot set left. So this one's in our link binary tree. It's a binary tree node, and we can test them. So if it may not work right away, we can make methods to get and set as we go. If we need a getter and setter in binary tree, we can try to create it. And if we need a getter and setter or accessor and mutator in linked binary tree, we can create it if we need it. If it's not working, you can test different things. You can try the dot root, and we can method chain here dot set left, or I guess that's an instance variable chain. So we can say, okay, so tree.root will set its root.set left. So we're going to be doing a little bit of that, practicing with the traversals, setting the nodes, the roots, the left childs, and the right children, and those left and right children, and so on. So we could have said, well, tree.get root node. Then we could have did parentheses and we could have said dot set left. So you can play with it like that just to test it out. But right now we're not going to do that. We're just going to say tree.root. If tree.root is equal to null, and again we could have said if tree.getRoot. Whoops. Get root node is equal to null. Does that work? Get root node. Right, that works I think, so that probably might work. If not, this one works for sure, so we'll say tree.root. We'll just access the instance data directly, why not? So we'll say tree.root. If tree.root equals to null, then we'll say okay, well we're going to say string user equals, so we already have string user, string points to y, then we have our condition, then we have current node points to tree.root, then we have if tree.root is equal to null, then we'll say here tree.root points to new binary tree nodes. So we're going to instantiate the root from null to a node now, to an actual root node. So we're going to say new binary tree node of type string object. It's going to store a string, and we'll put a string here in the parameters for the element, and we'll say ru in comp2231. Like if one of your peers were asking or something, like a friend or whatever in your class. Tree.root equals, okay, that works. So then we'll have, so that's the root now, this is a string it's holding, so that'll get its own memory location. Then we'll say current node is reset to point to tree.root. Then we'll system.out.println. Println. The same thing, ru in comp2231 question mark press or enter, whatever. Press Y, YN. So you can press either Y and N on your keyboard. That should be the end of the string. So it's going to print a message to the user. Then we'll say user string points to scan.next line, so it's going to get the user input from the user by the keyboard. So then after that, so we have this, if tree is .root is equal to null, then else. If tree.root is not equal to null. So if tree.root is equal to null, execute these statements. If not, we'll have some other statements. So we got quite a few of these to do, so we'll just get on to the next part. So if tree.root is not null, then we will say else. We'll say else here. So if root is not equal to null, then we'll say if user str dot equals ignore k. So this is going to be pretty repetitive. We're just doing the same thing we just did over and over again with different strings and stuff. So it's good practice at least. step we're going to be using set left child and set right child, get left and get right. So it's good practice for traversing through your own tree. It's a good way to, this is a good video to set, to learn how to like set your nodes for a tree and stuff. So if user string dot equals ignore case y, then we'll have a nested if, and we'll create a binary tree node of type string object. We'll call it node 2, because a lot before we called it just current node. So now we have node 2. We could have just called it node 1. But then we'll say binary tree node string node 2 points to new binary tree node of type string. And we'll pass a string in here as parameter for the element. Have you finished all the assignments? So what's going to happen is this is a decision tree, so it's going to be like, okay, well, so initially user string is going to be set to y, then while it is y or n, so it's just kind of like an automatic step in. Maybe we could have did while true there as well. We'll say string current node points to tree.root. If root is equal to null, then it'll ask you, are you in comp 2231? System.out.print, are you in comp 2231? It's going to ask you yes or no, are you in comp 2231? So on our keyboard we're going to hit Y or N. So after that, it's going to loop and probably check up here. Because after this if, right, it's either if or else. So after that else, let's just see what I have. If else, if root is equal to null, then it's going to loop back around and then check again. Check if root is null, something like that. Then we're going to, so if it's tree.root.null at this point, it's not because we have this, right? Then it's going to be like, it's asking, are you in comp 2231? Then it'll come back down here probably, yes, and then it's going to ask, have you finished all the assignments? So then we're going to do the same thing here, yes or no. Then we're going to set the left and set the, or set dot right or something. Okay, so where are we? There's quite a bit to do here, so just don't worry, might be a few parts, that's okay. So just trying to find where I am. Okay, so current node here. I'll say current node. So we have this line here. Is that too big? Maybe I'll just move that all the way down. Then we'll say here, have you finished all the assignments? And we'll say current node dot set right. So current node, which is currently pointing to the tree.root, as we can see. Then we'll say, okay, well, tree.root, set your right to node 2. Because if it is y, then we're going to say, well, y goes to the right, remember, and no's go to the left, I think. So we'll say, okay, well, if you did select yes, then we'll say, set the next question to, have you finished all the assignments? We'll put node 2 in here. Node 2. And we'll say, okay, well, current node, which was root, now points to current node. Current node points to current node.getRight. Current node.getRight. Then we'll system.out.println. The same thing. Have you finished all the assignments? Because we're going to ask, and then if it's true, then we're going to store the string in the node. So have you finished all the assignments? I could have perhaps created a string here, like string str points to, have you finished all the assignments? right? Then we could have maybe put str in here and str in there. But I wasn't thinking, and either way works. Doesn't really matter. That could work too. Sometimes when you're creating something, then later you're like, oh well, I could have did that. But this works too, so it's fine. We'll just do it this way. I already have the note set up to do it this way, so you can try that way too. So have you finished all the assignments? That would have been also maybe a better efficient way to make this code. So have you finished all the assignments? The assignments question. Finished all the assignments question, and then space y or n. Then we'll say user str points to scan.next line. Then we're going to say here in that if, we're going to continue with another if user str dot equals ignore case y. So if user str dot equals ignore case y, where were we? So we said, have you finished all the assignments y n? User points to scan dot, user str points to scan dot next line. If user str dot equals ignore case y, then we'll create a binary tree node of type string. We'll call it node 3. And we'll point it to new binary tree node of type string. And we'll say, have you finished all the quizzes? Have you finished all the quizzes? Yn. Y. Oops, did I mess that one up too? Above. Yn. So it's like a capital Y and an N, kind of like a command prompt. So we'll just do it like that. Yn. Don't forget the second bracket, square bracket, and then we'll close that line, and then we'll say, have you actually, sorry, it was have you finished all the quizzes? Is that correct? Yeah, that is. Is that getting too much, too big? Then we'll say here, current node dot set right to node 3. Then we'll say current node points to current node dot get right. Then we'll system dot out dot println. Where are we now? Have you finished? We'll do the same string again. Did I put y and n in that one? I might have. So we don't need y or n in here. I don't think it would really matter, but for the structure, but for these strings we need them like this. So in the node we're just going to store the string, and in the system.out we're going to store it with the selection. Then here we'll say user str points to scan.next line again. Then we'll have another level here if we're going to finish most of the y's first, I think. Then we'll say if user str dot equals ignore case. excuse me, we'll do y again. Then we'll say binary tree node. Did I put type T? It's not supposed to be type T, it's supposed to be, so we have the quizzes, user points to scan on next line, so this is a binary tree node of type string, not T. We'll say node 7 points to a new binary tree node of type string. Finish the labs. Then here we'll say current node dot set right to node 7. Then current node points to current node dot get right. Then here we'll say system.out system.out.println. Finish the labs. Then we'll just say end of decision set. So these are the ends of these are the end. This is the end of the y's. So end of decision set. Sorry, I'm still waking up here. So we'll say break. We'll use a break statement. So today's Remembrance Day. I'm not sure what they call it in the States or in your other countries. I thought in the States they call it Memorial Day, but I'm not sure if that's a different holiday. So happy Remembrance Day. Enjoy your holiday. Here we'll put so here we'll have an else. So now we're gonna nest them like this. So if it's not y, then we're gonna put the n here. Well, if this is not y, then we're gonna put the n below there, and if that's not y, then we're gonna put the n below there. So it's a little confusing, but you'll see it's gonna work. So here it's just gonna be else. So if it's not y, it's gonna be n. So we'll just put if user str equals n, because it's gonna be our condition. If it's not y, then it's n, or it's something else, but that should be fine. We can't really put an else. Actually, maybe we could have did an else if, but this way it works. So we'll just say if user str equals n in a comment. Then we'll say else binary tree node of type string node 8 points to new binary tree node of type string. Sorry, not T, of type string. Then we'll say here finish the quizzes as a string. Then here we'll say current node dot set left now, because we're going to do the end, so it's going to be left dot set left to node 8. Set left, where am I here? Let me just move my notes down a little bit. So node set left to node 8. Then here we'll say current node points to current node dot get left. And then we'll say, so this is going to set it up for the next one, I think. So here we'll system.out.println. it's kind of going backwards. The ends are going to go backwards unless we do them kind of differently, which is going to kind of mess us up on the brackets. So we'll just say system.out.print ln finish the string, finish the quizzes. Finish the quizzes. Then we'll say end of decision set. End of decision set. And we'll call the break statement again to exit the loop. Then below that, there's supposed to be 2 brackets. I'm not sure why that is. Well, at this point, when I did it, it was easy because I was like, okay, well, if it's Y, then do this. If it's not, do that. But this one, we're going to say, okay, so let me just have a look. Let me just look at back up here. So if, where does this one go to? So okay, so it's going here. So it's saying, have you finished all the assignments initially? So then here, if we say else, so if we didn't, it's going to be if. Again, it's going to be if user string equals n. Then we're going to say binary tree node of type string. Node 4 points to a new binary tree node of type string. The element will be, did you finish assignment 1? You can put whatever strings you want, like whatever questions you have. Then here we'll just have current node dot set left to node 4. Current node dot set left to node 4. So it's going to set the node to node 4. Then here we'll say current node points to current node dot get left. I spelled that wrong. Current node dot get left, so it's going to set up for the next node. Then we're going to system.out dot println, did you finish assignment 1 question. Then we'll do the y or n thing again. So y or n. So sorry, I've lost my spot. So where is it? So did you finish assignment 1? Current node dot set left. Then we say system.out.println, did you finish assignment 1? Y or n. And we say user str points to scan.next line. That node's done. I'm just going to take a sip of my water. Alright, excuse me. So after that, we'll just continue. So user str points to scan.next line. Then we'll say here, if. So we have, did you finish assignment 1, y or n. Below that, we'll say if we did finish assignment 1, so if user str dot equals ignore case y, the string y. Technically it's the character, but we didn't set it up that way. So we'll just do a binary tree node of type string. Whoops. Binary tree node of type string. Call it node 9. Points to new binary tree node. of type string, and we'll say finish assignment 2. Finish assignment 2, so this is maybe the end of that set. Then we'll say, is that the right place? Did you finish assignment 1? Finish assignment 2. Current node dot set right to node 3. Sorry, node 9. So current node dot set right to node 9. Then we'll say current node points to current node dot get right. So it's going to traverse to the next child. So it's going to be like, okay, this is a node, and we're going to say current node points to current node dot get right. So it's going to say current node points to its own right child, or its right sub tree, or sub child, yeah, sub child. Then we're going to say system.out dot print line, and then finish assignment 2. Then we'll just put here, we'll just note that it's the end of decision set. If you wanted to make the tree longer, of course you can. Then we'll say break here. And below here, so if one of the answers to one of the questions maybe above here, did you finish assignment 1? If it was Y, then we'll do this, and if it's N, we'll say else. Binary tree node of type string object. We'll call it node 10. Points to new binary tree node of type string. And we'll say finish assignment 1. Or sorry, finish assignment 1. That's it. Then we'll say current node dot set left to node 10. Then we'll say current node points to current node dot get left. Then we'll system.out dot print ln. Finish assignment 1. Did we already say this? Finish assignment 2. No. Finish assignment 1. End of decision set. Do I have a typo on this? I think no. It's an exclamation mark. Okay. Finish assignment 1, and then we'll say here end of decision set. Nope, the quote doesn't end. Finish assignment 1, end of decision set. Then we'll put a break statement here. 2 brackets. We'll move this one up. And we'll have an else, actually 1, 2, 3 square brackets below. We have an else, so where does that one go to? So if one of the questions was, have you finished all the assignments? So if here we put Y. What's up with that? Why is it doing that? So have you finished all the assignments? So we say 1, 2, 3. So maybe this one's are you in comp 2231? Then it's asking the root. Then we'll say this one's have you finished. So no, this one's finish assignment 1. End of decision set. Then 3 square brackets. This one goes up to, yeah, so this one's going to be if you selected N for are you in comp 2231, I think. So we'll put an else here. Then we'll say binary tree node of type string. We'll call it node 5. We'll set it equal to new binary tree node of type string. And we'll say did you complete comp 1231? question mark. Then we'll say current node points to, or no, we'll say current node dot set left to node 5. Then we'll say current node, or points to current node dot get left. So current node points to current node dot get left. Then we'll system dot out dot print line. Did you complete comp 1, 2, 3, 1 question mark, and then y or n, like that. Then here we'll have user str points to scan dot next line. So then here we'll say, okay, well, if you did complete it, I think we're doing that in that bracket actually. Sorry, in this else statement we're going to have, what's up with that? Else without it, should be. Great. One of the brackets is messed up. That's very helpful. Let's see. So I said 3 brackets after this. Sorry, so I'm gonna have to go back and check. There's a bracket mismatch somewhere. Did you complete comp 1, 2, 3, 1? Where are we? Did you finish? Did you complete comp 1, 2, 3, 1? Right, that's where we are. So above that we have 3 brackets. One, 2, 3. Then we have an else, then an if, else, if. No, I think there's something wrong here, else. So we have finish assignment 1. Then we have finish assignment 2. They have did you finish assignment 1? Yeah, that's right, so else and then ifs, else, then if, okay. Something's up here, 2 brackets and then 1 bracket, 2 bracket. Okay, so I might actually just start from the top just to check it out. So we'll say public void add node. So we have our while, we have our method, we have our class, method, then we have while, then we have if else, so if tree.root is equal to null, then we have else, then if, then if, then if. That should be the last if, then we have an else. So if, and then else. So if and then inside if else and then 2 brackets, that looks alright. Then we have else. And we should have 2 ifs in here. Okay, this is where we went wrong here. We got a bracket here. So I think we have else, then this statement, then if. So we had an extra bracket there, so take that one out if you did. Have that there, and then we'll say if user str, this line, if. So we have our else here, if. else, if, else. I think these are supposed to be indented, but it got messed up because of the bracket, so we'll just try to indent them now. So I'm doing that with tab. So we're saying, okay, else, if else, then 3 brackets. This one moves back out here, you know, like that. And this one moves up a little bit. Maybe could have just hit tab. And then this one moves out a little bit. Can I just space that? Okay, so you have 1, 2, 3, and then else. That should be right. Did you complete comp 231? Else if user str. Where are we now? So else, here we have an else statement, 3 brackets, 3 square brackets, and then an else. Then we have node 5. Did you finish comp 1, 2, 3, 1? And then we have, at the end we have user str points to scan.next line. Then in that we'll have an, in that else, we'll have a space here. Then we'll say if user str dot equals ignore case. Y. And we'll create a binary tree node here of type string object. We'll call it node 4. We'll set it equal to new binary tree node of type string. Tree node. Actually, sorry, where are we? Did you like, so node 4, right? Did you like JavaFX? Did you like JavaFX? What's up with that? Oops, node 4 points to new binary tree node of type string. Element will say, did you like JavaFX? Then under that we'll say current node dot set right. Current node dot set right to node 4. We'll say current node points to current node dot get right. Then here we'll say system dot out dot println. Did you like JavaFX? Again, y over y/n. Then we'll say user str points to scan.next line. So then we'll say if, another if, so if user str dot equals ignore case y, the string y. Then we'll say binary tree node of type string. Call it node 11. Point it to new binary tree node, so we'll do an instantiation. of type string objects, and we'll say learn Java SQL. Then we'll say current node dot set right to node 11. What happened there? Binary tree node. Okay, spaced it here. So node 11 points a new binary tree node. Learn Java SQL. Current node dot set right to node 11. We'll say current node points to current node dot get right. System.out.println. Did you like Java? Nope, that's wrong. So we have binary tree node, string node 11, current node dot set right to node 11, then current node points to current node dot get right, then system.out learn Java SQL, and then that should be the end of decision set. We still have a few more to do though. End of decisions. Not set. Did I say set before? We'll have a break here. Then 2 brackets. So else. Nope, that's wrong, sorry. So we have our break. Then here under that we'll say, okay, well, if you did like Java FX, then we'll have the SQL, we'll say break. Then under that we'll have else. Binary tree node of type string node 12 points to new binary tree node. I'll learn JavaFX. We'll say current node dot set left to node 12. We'll say current node points to current node dot get left. So current node points to current node dot get left. System.out. Learn JavaFX. End of decisions. And a break for end of decisions. Then we'll have 2 brackets. And we'll say else. Where does that one go with? I'm not sure, so don't worry about it. We'll go through the decisions after in the system.out. Maybe we'll do some debugging too. So how much do we have left? Just a few more. Actually, maybe this is just the last 2 here, or 3. Then we'll so there's an option to fill the tree using a brute force tree traversal. We'll probably go through that too. So we'll do that after. We'll just finish these up first. So binary tree node of type string node 12 points to new binary tree. where we learn JavaFX, break, then we have two brackets. Then here we have an else, then here we'll have, okay, now it's saying else without if, great. Should have been only one bracket there. Okay, so we have two brackets, so we have if. Did you like JavaFX? Then nested if. Learn Java SQL. And there should have just been else here. Learn JavaFX. There we go. Hopefully that makes it. Okay, and then we'll say here. So where were we now? So we have learn JavaFX, and then we have else. I'll learn JavaFX, break, two brackets, then else. Then here we'll say binary tree node of type string. We'll call it node 6. Points to new binary tree. Node of type string. Did you complete comp 1131? Current node dot set left to node 6. Current node points to current node dot get left. System.out println println. Did you complete comp 1131? Question. We'll have the Y or N here. Then we'll say user str points to scan.next line. Under that we'll have a nested if. So else if here. User str dot equals ignore case y. What happened there? Binary tree node of type string object named node 13 points to new binary tree node of type string object finish Linux and C. We'll say current node dot set right to node 13. Then current node dot set right to node 13, and then current node points to current node dot get right. And we'll say system.out dot println finish Linux and C, then end of decision set. We'll have a break, then if else, then we'll have binary tree node of type string here, node 14 points to new binary tree node of type string, and we'll say finish comp 1131. We'll say current node dot set left to node 14. Current node dot set left to node 14. Current node points to current node dot get left. That might point to null, I'm not sure. We have to check, we have to test it out. I think it might point to null if it's the end of the tree. System.out.print line, then we'll say finish comp 1131 end of decision set. Break. There we go, and then we should have 1, 2, 3, 4, 5 brackets. 1, 2, 3, 4, 5, 6. Looks like there's 6 brackets. Close else. Close the outer else. Close the else above there. Two more, and then we'll just close the last one. Hopefully that works. Actually, no, it's in. No. It's not liking that. Which is this? Can't have more than that. So 1, 2, 3, 4, 5, 6. Oh no, yeah, that's right. Actually, we actually might have 6 classes, 6 brackets. 1, 2, 3, 4, 5, 6. Sorry, 7, because we closed the class as well. Here we can do our next method. So hopefully we'll test that out. I'm just going to take a break and we'll come back.